Hello, everyone. I trust you're doing well today. We have come to the third day of this series, and today we shall be looking at oil injected compressor 201. That means we are going to look at some advanced technology in oil injected compressor. So I would like you to pay attention as we go through this series. This is an unloader valve. I want to take each of these parts, major parts in an air compressor one after the other, so that we'll be able to appreciate it as if it was in real life. This is an unloader valve assembly, and the unloader valve assembly comprises of unloader housing, which is this, the blow valve, which is this, and the solenoid valve, which is this. The solenoid valve is an electrical part. Most of us know what a solenoid valve does. When it energizes, it can move its plunger to allow a flow of air or something, mostly air or liquid, like in hydraulics also. So this is the unloader valve. This is the inlet from the air filter. From the air filter, when this unloader valve opens, it allows air to go through the air filter and it goes to the element. Then compression will occur. Without this unloader valve opening, there cannot be any compression. So I will show you in details what it looks like inside of it. This is when you open the unloader valve, what it looks like. And this is how it is being mounted in an air compressor. This is the air end, electric motor. This is the air filter. And this is the solenoid valve and blow valve assembly. And there is a control air from the separator which opens, which pushes down the valve whenever the solenoid valve is activated. So majorly basically the function of the unloader valve is to allow air to enter the compressor element when required to load and to shut off the air to the element when not required. So basically it regulates compression. This is the vacuum control type, and this is commonly used by some major brands. We also have the spring loaded, but the vacuum control type is cheaper to maintain. So popular brands are going for it, knowing that it will make their compressor easily marketable. Well, unloader valve is always rekitted. These things you see are the kits. There are some O-rings, and these O-rings are usually rekitted after every 8,000 hours. If you don't rekit it, it may fail. Then you may have a situation whereby you need your compressor and it is not loading because the unloader valve has failed. So every 8,000 hours or every 1 year, we rekit it. Okay? So basically, this is when you extrude it, what it looks like. And this is also a diagram showing the control air and all that. Okay, this is when the unloader valve is unloaded. What do we mean by unloaded? When it is not open. When it is not open, it does not allow air to flow in. So compressor will not yet give you any pressure. Will not build up pressure. It will only give you the minimum set point. Now this is the solenoid valve. The solenoid valve will get de-energized. It will receive the signal from the controller. From the electronic controller to receive the signal, it will de-energize. And when it de-energizes, the spindle will close. And once this is closed, this is a piston. Once it is closed, air cannot go from receiver. Look at this is from receiver. And this is the air that goes to open this. So when this air cannot go, then this will definitely close because no air again is pressing down from this top. So when it closes, the blow down valve will open. and all this air which were inside will vent out to the atmosphere. So when a compressor is unloaded, the solenoid valve de-energized, the receiver pressure is under the piston. It cannot go through the piston. Inlet valve closes. This will close, and blow that valve will open to push out all the air which is already inside. Now, this is a case when the unloader valve is loaded. Now, in this case, the air will go from the top. You see it has pushed this down, and this has opened. If it is in a closed position, this will come here, and this black spot will come here, and this place will be sealed, so air cannot go in. But now the air has gone in here and pushed this down. So the air from atmosphere at 1 bar can go through to this place, and it will be compressed by the element. So when loaded, the solenoid valve energized, no receiver pressure under the piston. Look at the receiver pressure off gone right inside. Vacuum from element under inlet valve. Then inlet valve opens and blow down valve closes. This has closed, it cannot vent out air to the atmosphere. This is still extruding it, just I've extruded it before. So this is just simply what it looks like. Look at your blow down valve. The solenoid valve is sitting on it, but the picture is not here. Then these are all the parts. During every 8,000 hours, you need to rekit it. This seal, you need to replace it here. This one also, there is a seal here. Then the key, you also need to change it because it can get broken. Then this O-ring, you know, then this seal will come, a new one will come. Those are the things we need to rekit with these little O-rings. Otherwise, it will break down. This is an electric motor, air end, and gearbox combined together. This is the air end. There are two gears, one for the air end and one for the electric motor. This is actually the gearbox. This what I did from here is the electric motor. Now, if this gears, we need to know it has a very significant role. If a compressor is a 10 bar compressor, the gear ratio will change from a 7.5 bar compressor. So, assuming you are an expert in compressor and you're overhauling a compressor, or you're asked to quote for a compressor overhaul kit, you must take cognizance what pressure it is before you do what, before you order these gears. So these gears are ordered according to the pressure of the compressor, because once the gear ratio changes, the speed of this element changes and the pressure immediately changes. This is the element. This is it. And the function is to compress the air to a working pressure. Whatever working pressure you set, if you set 10 bar, for a 10 bar, a compressor that has up to that capacity, immediately the speed will increase to 10 and it will give you 10 bar. If you set 8 bar, it will reduce the speed and give you 8 bar. So this guy runs according to set pressure, and it does not do this on its own. It gets signal from the module, and the module will do what? The module will also regulate when the unloader valve will open and close to be able to get to this point. Okay, this is right inside of the element. You can see the bearings. You can see these are the keys or ring to avoid leakages. These are the male and female rotor. And you can just see all the parts. There are four bearings at the rear side, but there are two bearings at the drive end. This place is called the drive end, and the rear side is called the non-drive end because the motor drives from this end. But anyway, do not attempt to do this yourself. Always call the manufacturer representative. If you do this yourself, I bet you will lose the element. And this is more than 70% of the cost of the compressor. It may look small, but the cost of the compressor is in the elements. Check valve. Actually, this is a check valve oil stop valve assembly, but for now we are looking at the check valve, which is this part of it. Now, what it does, it prevents air to flow back to the elements. If this element is rotating and air suddenly flow back in the opposite direction, you're causing harm to the bearings, in fact, to the entire elements. So the OEM had to build in a check valve to avoid backflow, backflow of air to the system. And so that is what the check valve does. And it's spring loaded. So once air wants to go back, it pushes it, the valve, and closes it. Look at the valve here. You can see it's spring loaded under it. So it comes up and it closes this chamber where the air should come out from. This is the air oil vessel. Is simply stores is actually serve as the reservoir where the air and oil comes after compression, and it also the place where separation occur. First, like I told you, there is a cyclone movement which helps separation. We are going to see that as we go down. So this is what it looks like. This is the cover. This is an O-ring. Then this is the oil separator. There is a protector here in order not to allow that high pressure air to be hitting the element directly, the separator directly. If it does hit the separator directly, then the separator will fail prematurely. So that is why we have this one to give you some protection. Then this is the reservoir. There are some, this is oil level indicator. Then there is a drain point at the base. So that is it. There is also a safety valve here so that if this element get clutch, maybe you didn't change it and it gets clutch, instead of this to explode, this safety valve, when there is high pressure, because when it's clutch, pressure cannot go, instead of it to explode, the safety relief valve will open and this will purge out air. Then this is the minimum pressure valve. We are going to see it down. So separation occurs in three stages, like I told you, cyclone. Because of this, the design, it has to go like a cyclone. Then direction change, some goes down, some goes up, the air goes up, then the filter itself also, the oil separator filter. This minimum pressure valve, it is mounted on top of the oil receiver tank. You can see the cover of the receiver tank and look at the housing where the MPV, minimum pressure valve, is mounted. And this is just the kit. You can see the valve, you can see the spring. This spring is 4 bar tensions. There's also a smaller spring too for this place, but this is the 4 bar spring. Okay, so this spring will not allow this to open until it attains 4 bar. So the major job is to ensure that there is enough pressure, especially during starting, to circulate the oil. Otherwise, the compressor will get damaged if the oil does not circulate. This also helps in separation. If we have up to 4 bars, so it is easy for directional change and cyclone motion to happen for you to have an effective oil separation. We have the aftercooler. This is the aftercooler here. And what it does is simply to the hot air, which is compressed, leaving the compressor, it cools it down. Okay, so that there will be no water vapor in the system. After cooling it down, the strainer will strain the water out of the system. This is the cooling fan. Mostly now, new technologies they find that the radial fan is more efficient because it has high volume. So this is a radial fan. It is this fan that extracts heat from this heat exchanger. Then the oil stop valve, like I told you, it is inbuilt to the check valve. This is the oil stop valve right here. And what it does, it regulates the amount of oil that floods the element. During loading, it allows, when the compressor is running, it allows the oil to go to the element. But when the compressor is not running, it shut down oil from going to the element. Otherwise, what happens is that the element will become flooded. When you want to start the compressor again, it will be carrying so much oil that most of the oil will go out of the air filter. So the oil stop valve regulates this. This is what the oil stop valve looks like. Well, I won't talk much about electric part of the compressor today, but maybe in more advanced course. Actually, I've decided after this course, I will be running a paid course, not quite immediately, but maybe after some weeks or some months. So in that time, we'll be able to go more advanced to talk about both the electrical cubicle and some other functions, which we will not be able to cover in this preliminary course. But then most electric compressors use ABB, some use Siemens, mostly ABB and Siemens. There are some other technology if you go to Chinese compressors, but most European and American compressors use either ABB or Siemens. Well, if you can see here, we have the contactors. We have the data contactor, the star contactor, and the line contactor. So normally your compressor runs at 400 volts. So first you have the star contactor will come in, and after which it will switch over to the data. This is to absorb the consumption of power. Then when it switch over to data, it will now run on delta. So later on, as we proceed in this other advanced course, I'll be able to tell you how to troubleshoot when you have electrical challenges. Okay. Then we also have phase sequence relay. What a phase sequence relay does is to ensure that if the motor is rotating in the wrong direction, the phase sequence relay will trigger and the system will off. It's a protection for the motor, knowing that if the motor goes wrong in wrong direction for a long time, the element can actually be damaged. So this is the star data connection, how it's being connected to the electric motor. And you can see we have the main contactor, star contactor, data contactor, overload relay, and this is actually 400 volt supply voltage. These are safety precautions which you must take while carrying maintenance or repair on an air compressor. I will be sending you the safety precautions so that you take note of them should you become an air compressor engineer so that you don't run into crisis. This is where we are going to end the lecture for today. And let me see if I will be able to play a video for you. Though this is not on, it's still on oil injected compressor, but not on a screw compressor. That will be on a scroll compressor. Okay. Okay, this is rather a double two-third compressor. So you see how it compresses from phase one to phase three. We have the intake, we have the transports, look at the transports, then we have the delivery, compression, then we have the delivery at this point. So you can see it at this point. This is female rotor, this is the male rotor. There are more videos, but maybe in the advanced course, we can look at them in the advanced course. All right, this is the end of our segments, and this is the end of this training. Tomorrow we'll have a live section to take your questions, and whatever confusion you have, put them down during our advanced course tomorrow or during our live section tomorrow. We can take all your questions. Thank you very much. If you're interested to see more videos in future, maybe on some other things like business, you can subscribe to my channel. Have a nice day and enjoy your day.